So TIFR Hyderabad, how many of you have heard of TIFR Hyderabad? Oh, yeah. All right, so TIFR, quite a few. TIFR Hyderabad happens to be it's a research institution that is, I think, how many of you attended the first session? Because I have to give a long introduction about TIFR then, and then how TIFR came in, but I think that's something I'll let Professor M. Krishnamurthy do. But the idea is, this institute, which is growing to be one of the most premier research centers in the country, has a strong emphasis on interdisciplinarity. The idea is we will no longer do science in silos. We will decide to collaborate with people from other disciplines, try to answer a scientific question, discipline no bar. Okay. Now, true to this nature, today TIFR Hyderabad scientists, Karthik, who is a condensed matter physicist, and MK, we call him, he's a center director actually, Professor M. Krishnamurthy, we lovingly call him MK. And both Karthik has been looking at something which he's also going to discuss in the panel today, spintronics, condensed matter physics. And I won't explain those terms because that's all Rajashekhar's job over here. So, so these two physicists today have decided to push these boundaries of interdisciplinarity and cross into the realm of comedy. And they are going to collaborate with a stand-up comedian, Rajashekhar Mamidanna, who's one of the most popular figures in comedy in Telangana. And I'm really looking forward to this conversation, as Rajashekhar is going to break down all the terms, and that both MK and Karthik have decided that they're going to explain and try to explain these buzzwords in physics today that has been occupying all, I think, newspapers, social media feed, anything about new science news, that what is quantum, what is fusion tech. So they're going to break down those terms for us, and Rajashekhar is going to help us understand those terms along with them. So with that, I'd like to give this to Rajashekhar and take this discussion forward.
Thank you, Anushila. Can we have a round of applause for all of you for coming up here, and also our esteemed gentlemen here, Karthik and M. I think, first of all, I want to clear that it's too much expectations from a comedian. I was just talking to them outside and I realized that all three of us are under pressure. They are under pressure to make it comedy and I am under pressure to match up to their IQ levels. I think I'm glad that you guys are also under pressure, but thank you so much. We'll start off with the first question. I'll start off with MK. Please tell us, all of us, what do you do actually in TIFR?
I am a laser physicist. Basically, we are using very, very high-powered lasers to create a matter as high in temperature as core of a star like sun. So in the sense, we know only superficially what happens on the surface of the sun. What is happening inside where the temperature is 1,000,000 Kelvin and the density is very, very high because there is so much of gas sitting on the what is there inside. So there is no way for us to be able to sample this to understand how the laws of physics work there. So we want to create that in the lab using modern day lasers, and that's basically the basic research.
I'm sure all of us understood every term. I'll ask questions, okay? This is not a session anymore, it's a Q&A, okay? Can we have a round of applause for MK? Thank you so much. Now coming to Karthik, so please tell us, what do you do?
Yeah, hi. So I primarily work, and as Anushila just explained, work in condensed matter physics. What it means, basically looking at electrons, how they flow in all kinds of materials. I'll take a very simple example. You can see outside people walking around, right? Imagine every person is an electron out there, and they are just moving erratically in all random directions. And that's something and that concept has built in all kind of technologies, whether it's your smartphones, what you're dealing with. But when you talk about in quantum domain, imagine suddenly outside, you have a flash mob. Suddenly you start seeing people dancing together in sync, in harmony, complete harmony, right? This is like a quantum dance. And this is specifically what we are exploring. We're trying to explore what happens when a collection of these particles or electrons in a solid do this quantum dance. And then the physics that comes out of this is very much interesting, very much novel, and only, lots of things to explore. And this has relevance to all kinds of applications, though it's very fundamental, but these fundamental questions that we address in our lab helps us to really take it forward, develop new ideas, develop new concepts, develop new technologies eventually, whether it is in defense, in communication, in storage, in information processing, and all kinds of things. So the quantum is now become a buzz, which is eventually leading us to, building next generation technologies. And that's something's already here. We can take specific examples as we go ahead, but this is something that we do in our lab, and we are excited to really take this forward and contribute.
Thank you, Karthik. You have to keep applauding the scientists whenever you can, okay? So I think in this, I understood few words. I don't know about you, but I understood flash, dance, okay, and electrons, I'm sure all of us understood. Okay, but taking the cue from, because I've seen a lot of Marvel movies, Avengers and everything. So where there's one movie called Quantumania. How many of you have seen that movie? Yeah, you acted in that? No, you've seen that movie, yeah. So in that one, same thing. They go into the quantum world and then everything changes. So from both of you, can you explain to people like me, I think, which most of them are intelligent, only for me I think I'm asking this. So what is quantum world? What is happening there? I really like this looking at each other. This is amazing. I mean, it just shows that we are on the same page. Okay.
So,
Absolutely. Go ahead.
so basically, when you say classical, it is something that you can measure continuously, and for example, a ball moving. So once you measure the motion, you can tell the next moment where the ball is going to be, and after that, where it is going to be. But when you go down to a microscopic particles like electrons,
Which is quantum world.
which is there, because of the energy and the mass and things which are very, very different, it's very difficult to ask this kind of question as to how things move. Because
So you don't know where the ball is going.
it's like, when I say a wave in a sea, where is the water moving? The water is not moving anywhere. Actually, the water is just going back and forth, but a wave is going. Right? In a stadium, people just get up and sit back at the same time, but there is a wave that is going. So imagine quantum is like that. The physical motion is classical, but there is a phase that is going around, or a bump that is moving around.
So because of the physical motion, we get the illusion of the wave.
Yes.
We are suddenly in the Sadhguru territory now. Like I'm very happy. Yeah, okay, got it. And you
So
want to add
I'll
anything?
just add on to what MK said. So let's take a simple example, how gravity was formed. You have an apple. Newton's laws equation came just by looking at how an apple falls down, right? And that's something deterministic. You know exactly if you drop an apple at this time later, you will have the apple on the floor. That's governed by the equations which you all have seen around. But in quantum world, we are actually working in a different law where we only talk about probability. We talk about the fact everything has a finite probability. Even let's say me breaking through this wall and going across just by hitting hard has a finite probability. It's not zero, it's always a probability. So if I do it for, let's say, a million years, just keep hitting the wall, if I survive that long, I'll eventually end up into the other side of the wall. So that's the probability
Yeah.
world that we are dealing with in the quantum systems.
So just to paraphrase both of you what you said, we are dealing with probabilities at the quantum world, whereas in the real world, we are dealing with more of a deterministic value.
Yes.
Like I know we will talk to each other, but in the quantum world, we may or we may not. Correct only, right? Thank you for the appreciation. I think I paid him. Did I pay you before the? No. At this point of time, if anyone has questions, please keep it to yourself, because I myself have so many questions. Now, second thing I want to understand is that, see, for a lot of us here, science is just a way of getting marks in school. Okay, most of us.
Same with me.
I mean, good to know. So now my question is, how can we develop that scientific mind? And when you are saying quantum world, we don't understand, then why are we even studying it? Why can't we just let it go? Why do we have to be adamant about knowing things which we don't know?
It's the fun of getting challenged
Fun of
and
getting
trying to defeat the challenge. Right? If everybody knows the same thing, then you're one among everybody. But you want to know something which others don't understand.
I don't understand. So you're having fun. You are definitely having fun.
So you want to be one of the few people in the world who suddenly sees something which has not been seen, has not been discovered, or not been explained. So to get to that unique position is a fun.
So your
And
take
fun
on?
for everyone is different, right? I mean, for example, someone would like to really become next cricketer. My son, if I ask him that question, what do you want to be? You want to be a scientist? He said, no, I want to be a cricketer. I want to be like Virat Kohli. But that's a passion that drives. Same way you will have some students or some people who are just passionate with having a curious mind to know why things are happening this way, right? And that's the curiosity that brings us all or certain people competing in an environment, saying that, okay, I would like to know this further, and that's how I think we all survive. We all survive with the competition, and that to some extent drives, apart from the passion that we inherently have in us too.
To put it in a simpler way, when a father brings a toy or a mother brings a toy, there are kids who are happy with listening to the sound, looking at the light and pushing it to make it happen. Some people who want to break it and see what is making sound. I
Wow.
think we are the people who want to break
Who want
it
to
to
break
see
it,
what is
okay.
happening.
I collect after you break it, I take it back and I assemble myself. Okay, so that's very interesting because now when you are talking like that, okay, definitely in the unique set of people who are having fun, trying to find answers to questions which we don't care. But I mean, we do care, like in some sense. But my question is, how can we incorporate this scientific method in our own professional or personal lives? Because to be very honest, I feel, it's my personal opinion, don't quote me anywhere, as a comedian, I can say whatever I want to. So I think in India, we don't have that scientific mind. Most of the public, we are not like looking at things in a scientific manner. But there's a lot of value in it.
See, I mean, science, it started in a very, very simple manner just to question, where the stars are, why are the stars blinking, or then it comes next question, can I use the stars to navigate? The moment you can use the stars to navigate, it becomes a useful tool. It is no longer just a record of what comes when, where, on which day. So over the time, science has become a fantastic utility. So most of the time, what happens in a real science is the side product, which is not really the kind of thing you need or to do, becomes the most important thing for the society. I mean, if you look at World Wide Web, it just came out because some people wanted to share files. The physicists in CERN.
Now all of us are sharing files.
So then today you cannot imagine the world without World Wide Web. So people are not making it for people to share files, but they have made it for physicists to share their data.
No.
But then somebody else gets to use it in something else.
Yeah.
So those of us who are happy with the fun of creating that, if people use it, well and good.
No.
And if it changes the world, even better.
Yeah. Your perspective, how can we incorporate scientific mind in our everyday thinking or life?
I think to some extent it's already there, it's just we don't realize it. And I think there are efforts, there are things that is happening where you have to drive or bringing that curiosity into these kids at the young age. And I think this is more of a serious question in terms of how socially we can actually engage in with this. But this is something I think every institute has realized that we are also at a cusp where we have a lot of people, a lot of children in the country under 21, and this is the right time where we actually get into these outreach modes, promote science, bringing that curiosity right at the early age, which is what is required to really get them interested. It's just at any other occasion, whether it is cricket, whether it is chess or any sports or any other activities. We have seen even music. The thing that is driven at the early stage is what they get passionate about.
Yeah.
So that's...
Okay, till now we have learned three things. One, quantum world is full of probabilities. Okay. Number two, they are having fun. I think we should also have fun. And number three, we should ask questions. Okay. On that note, if any one of you have questions, please ask them a question. What a transition. Okay. Anyway, yeah. So any questions? Yeah, ma'am. To them or? To them. Of course. Nobody asked me any questions. Please ask them.
At that time, doing science was cool. It was like, people, it was exciting, or at least maybe those are the people I was surrounded by, that's why I thought. So it was very cool to do science, study and fundamental science and, to hear all these things. Now, do you feel that that has gone, that has reduced? Because as a career counselor, when I'm talking to students, they're really curious about physics. They really love chemistry. And their parents will immediately be like, oh no, they'll join engineering. Why should they join engineering? They enjoy physics. They enjoy math. Let them study physics or math, right? I guess because there aren't, I don't know, jobs or whatever it is. But do you agree that thing of just saying, let's do pure science, that excitement, are you seeing a reduction in it?
No, I don't think it is actually reducing. It's actually increasing because the science is no longer seen as an esoteric thing that, it's not like an art that, that should be appreciated. It's a act that actually is going to touch everybody's life and changing people's life. It is changing people's livelihood, people's economy, people's ease of living or ease of going around things. So because of that, I think there is a lot more seriousness. I mean, but the confusion also is, science and engineering. I mean, application of science sometimes may take a precedence because, if somebody can make something helpful for thousands of people, he will definitely be paid more. He should be paid more. And so there is an ease with which he can get a job. Whereas if you do only basic science, maybe people have a fear that I may not get a job. But it's like, a classical music versus a rap music. I mean, classical music is there, but it's not going to go anywhere. May not many people practice it as rigorously as they will, but, rap musicians also may be practicing Carnatic music in the back, but they won't show it in the front probably, because without getting that touch of the music, you may not be able to do the rap music. So it is there. I think it is growing. Only thing is it's getting modified in terms of applications.
So basically, classical music is like traditional physics and rap is like quantum world. I don't know. Yes. And also, one more doubt, when she was asking the question, I was surprised. Engineering is also science only, right?
Yes.
Thanks. I mean. Because I was like little curious because computer science engineering I have done and then I'm like worried whether did I do. Okay. Any other question? We'll take one more question and we'll have questions throughout the session. But yeah, somebody raised the hand. Yeah. Yes, sir. And also, where is that guy? Somebody came from his wedding, I think. Where is that one guy standing here with traditional dress? He left? He came from a wedding? No. Sorry. That's how he dresses normally? She is a counselor. Ma'am, huh? Yes, sir, sorry.
Yes, chartered account, nothing to do with science. Standard.
I think the voice is
I
breaking.
think you're pressing the button. Go ahead.
I'm a chartered accountant. I have nothing to do with science. I left my last science class in my 10th standard. And my question to you all, seeing Elon Musk, what are your thoughts in your scientist community or your general science community? Is he defying physics? Is he defying science? How is he futuristic in thinking? Like quantum computing is what we are talking now. Where is he advanced? I want to hear your thoughts.
Your question is about Elon Musk.
Yes.
You take it.
Yeah. No, I don't think he's defying physics. He's optimizing many things better to be able to, and putting money where it can make it, more workable. See, it's like, the computers are there, but every day it is becoming smaller and smaller, easier to use. It's not creating something new, but it's optimizing things to a very, very high level of sophistication so that you can do seemingly very, very impossible things in a regular manner.
Taking example of Elon Musk. So I personally, of course, I've seen these movies of Iron Man and all those things. So when you see those movies, a decade ago, you used to feel, this crazy stuff where going to the basement and doing this kind of, and having an age, having a computer talking to you and, doing all those, calculations and, building manufacturing things in the basement. It was all look very crazy. But now if you look what he has done in some sense, he's taken those ideas, and obviously it was perhaps his own idea as well, to take it forward, challenge the community on what the potential is. Now he has invested in many of these. So he may not be a scientist, but maybe someone who's thought through a certain vision and taken certain leaps forward, which is helping the whole community in some sense. Maybe he's not the only one. There are many such examples like him. And I think it's at the end the vision and how we move ahead is most critical. And science has important role because without science, many of these ideas cannot be really implemented, right from instruments to the
And the
software.
money helps.
Yeah.
And also, I think as a chartered accountant, he was more interested in Elon
finance.
Musk's money. I don't think he's worried about science, correct only. I could see it on his face only.
But just to give you an example, if you go to US, let's say MIT, undergraduate program in physics, you probably have enrollment of 35 to 40 students every year. When they graduate, where they end up into? Majority of them, 95% into Wall Street. Okay, so that's a perfect connection that you can see that though doing basic science physics, you can ask me what's the relation. Because many of the models, many of the things that they learn during their coursework actually has very direct relevance in financial models.
So a lot of 95% of our youth end up in Amirpet Street. So that's
Or
equivalent
financial
to-
district here, okay, high tech.
Okay, we'll take the questions later, but I have one question to ask. So, like in traditional physics, I can understand, like if some scientists say that, okay, we believe in God and everything. So I want to ask the God question in the ever-changing world of quantum world. How does, where does this God equation fit in? And sorry to put you on spot, but do you guys believe in God? At least Sachin, I don't know, just...
We have to define what is God to say whether you believe in it.
Okay.
And the definition, I think, is different for different people. The God is a very fantastic construct that, as a humanity, we have come up with.
Okay.
Because there are many things that elevate us in a very different way, psychologically, physically, and in every way. So you have to construct your own God.
Who is your God? What is your God?
The science is my God.
Science is... Oh. Comedy is my God. What about you, Karthik?
I think it all depends. To me, I believe in God, but it all depends on probability. I'm really staying in a quantum.
So
living in
you're
a
not
quantum world.
denying, but there's a
It also
probability
depends.
of God.
If I'm in front of
existing.
my mother, for example, if he asks this question, I'll probably say 100%.
Oh.
but
In front of this audience?
maybe 5-10%.
How many of you believe in God? Raise your hands. I think you should increase 5 to 20 maybe. Okay. So another one I want to ask is so there's a clear gap between people who are doing the work in institutes like TIFR and everything and the general public. Most of the time we don't know what you guys are doing, and our perception of you being scientists is quite different. I thought you will be ungroomed and all, but you guys look very well groomed. I thought hair will be like this and everything, but so how can we change the perception of the public?
I think by interacting with us more, and
Okay.
we are not a very strange species.
They are not.
We can reasonably talk in a manner that is understandable and sensible. We won't bite anybody.
Oh, okay. That's very reassuring. you can't.
I think we have Anushila, I think, who's doing a fantastic job in engaging us with the general community. And I think it also would make a huge difference if people like you, for example, conduct more shows relevant to science, motivate people to at least have some sessions done in our institute. It will be a promotion for us as well.
Payment.
We are aided by Government of India, so
Oh, wow, okay.
we expect a generous contribution.
The probability of me getting a payment is less than.
No. we are hoping that you will give us the money.
I will give you money. Sir, I think this is the last session I'm doing. For the record, I'm not taking any payment now, so there'll be one guy standing with a hat outside, just drop whatever you can. Okay, the another one, while you guys are answering, I got this question is that, see, we all keep talking about science and everything, but at the end of the day, there has to be some mechanism. What do you think should be the approach? Because, like, for example, a lot of science is done by questioning and arguing with the viewpoints. Yes. So on that note, I'm going to put both of you on one more time in the spot. Do you guys disagree on any concept, and how do scientists argue with each other?
Almost
do you guys?
All the time we are debating with each other.
Okay.
We are challenging each other.
Can you give one example of, is there any one point where you both disagree with each other?
A lot.
Like, tell one for the sake of audience.
Well, how much money he should get for science compared to me?
Can you argue now? Just give a demo for 2 minutes. Yeah. You should be a science student.
See,
Yeah.
the next toy when it comes, or we have money to buy the next toy, who's going to buy is always a debatable point.
Okay.
And always, there is an urgency for everybody. So those are the things we debate on.
And both are right. He's also right, I'm also right. But the point is, we still argue who is more right.
So who is more right most of the times?
It depends.
Obviously, as a director, he
As
is
a director,
more
he
right.
is more right. Yeah. So okay. So now let's say for us, like if you have to give me a quick lesson about how to argue with people.
Okay, let's take any topic. In the sense, for example,
Any topic. Give me some topic, na? Fusion, sir. Sir,
Okay.
something which all of us can understand. Food. Food chain, okay. You should not be science student. Any other? Any simpler topic so that we know how to argue? Some simpler topic. Any? Who gets more budget?
No, that's a boring thing. Let's we
Yeah,
can.
some simple topic. Anybody? Yeah. Ma'am. What?
God.
God topic.
God particle.
So, particle. So it's a yeah.
Topic
person.
on God. Okay. So now again, there is a perspective, right? I mean, for some people, cricket is God. I mean, cricket is religion, and Tendulkar is God.
Yeah.
Right? I mean, it's a very nicely self-consistent world in that there is a person who has done superhuman things. So you can identify superhumanity as God. Mahatma Gandhi was a God for many people because, unlike regular human beings, he did something that is extremely challenging, difficult. Rama was a God because, he went after a big army as a simple, person who left the whole army, perceived, went through his perception, how to do it, how to bring it, so he didn't give up. He didn't leave. As a king, he could have married 100 more women at that time. But he wanted to stick to his wife. Didn't give it up at whatever cost. For somebody, that is God. Right? So each of us have a different concept of what is God. And I think all of us are entitled to that perspective. All of us should pursue that view.
So-
it does not mean that.
Sorry. Where does it leave us when we are fighting for the God? You had a point because you looked at me.
No,
You just looked at me.
I just thought maybe for the sake of it, let me interject and
Yeah, please.
Be against it.
Please intersect. Yeah, I would like to.
Debate.
Yeah, please debate. Yeah, I'll just.
No, I was just trying to say that, of course, he started off by saying that everyone is God or people who have really achieved in life are God. But other way of looking at it is they're probably, hardworking, they're lucky because just doing hard work is not enough. You have to be lucky as well. And so that's one argument.
So people who are lucky are God.
And hardworking
Are
could be God.
Could be God.
With a probability.
Okay. This is a great answer. Every time now, whoever argues with me, I'll tell them on a probability level. It will confuse half of my relatives because they don't know what probability is. Okay. So, yeah, ma'am, you had a point. Ma'am, you take the mic and argue. That's the. Yes.
Well, I think that was, very nicely, politely you got around the topic without arguing. I think we are talking about the God that we cannot see. Sun God, moon God, whichever God, the God that we cannot see. That is the topic.
Ma'am. Come here.
But in this specific case, actually, we both agree. We are on the same page where we do agree that we're not 100% believers in God. So we believe in science. So
You,
You have to just argue on that. This is the right thing. This is don't do this.
so you want them to fight.
really fight.
So,
really want us to fight.
so all of us have studied maths, right? When you don't know something, what you do? You call it X. And
Don't
try
know.
to derive and prove in your own way what is consistent meaning of X. What is the consistent value of X.
Not your ex. Ex.
There's a question.
Ma'am, you have still another argument? Yeah, yeah. Percentage of belief in science.
Oh,
100%.
by the way, 100% believe in science, but not in any person, not any particular concept unless we prove it for ourselves. So the path, 100%, the destination or the people who are taking us to that drive, not 100%.
So
In the
basically, there
sense-
is no authority in science.
No authority.
You can question anybody. You
Anybody,
can doubt
yeah.
anybody.
Absolutely. You can,
Yes, of course.
yes, it applies to God
But you
also in this
apply.
context. No, but that's what I'm saying, madam. What I'm saying is it's an unknown entity. You start with the value of X, you derive your own way, and then you are consistently happy with that value of X. Then your world is complete. You don't have to worry about what others think of that X.
This also as a society evolving, I mean, this specific question, I mean, if I ask, let's say, people who are over 40, raise their hands who believe in God, you'll probably see 100%. But if I ask these younger kids, and ask
See-
them how many really believe in God, more than 50%, you'll probably see a handful. I assume.
And by the way,
That's a generation which is changing.
So we can't see electricity, but there is electricity. Something like that. We can't see God, but there is God. Can I answer this question as a comedian?
Yeah, please.
I think we should take another question. Ma'am, sorry. We will argue it after. Ma'am, you came prepared only. I think you should be a moderator. Wow. Are you a stand-up comedian? Are you a stand-up comedian? No, right? Don't try, please. My job will be gone. No, but it's very interesting because usually I love the analogy which she gave, like electricity thing. So ideally, if somebody points that question before taking that question, how will you answer? Because that's a great analogy.
Yes.
I can't see electricity, but it's there. It's shocking, and I can't see God, but it's there. So what will you answer for that?
So just like the way you experience electricity when you touch the wire and you get a shock, the God also has to be experienced.
Mike.
So God also has to be experienced. If you don't touch the wire, nothing happens to you. You don't feel the electricity, right? So God also has to touch you. You have to touch the God and create your own experience.
So you're bringing it to subjective experience.
It is subjective.
Subjective
Obviously.
experience.
You also-
Yeah, even science is subjective experience because see, there may be a lot of science articles published, in newsletters. We do question still, for example, there's some work done by someone in US or Europe has published some work, and this is something very interesting, that we don't take it for granted that this is right. We first read through it, we argue about it,
You test it.
test it if possible in our labs or, speak to our colleagues who are more experienced. And then, it comes very slowly, gradually in terms of the confidence whether that particular science is right or wrong. But it's still subjective.
So basically, the process is about testing it.
Absolutely.
Like even if somebody says
So-
that okay, there is God, you test
So-
that premise without being disrespectful.
So even though for us Einstein or Newton are have done really outstanding, fantastic work, we don't admire them like God or a gospel saying that what they said is true. We want to understand for ourselves and see maybe they have missed something.
And somebody has a mic here. Yeah.
Yeah, hello everyone, and thank you for this interesting session. So here, I would like to add and also ask how do you perceive it? So for us, God is someone who has created this whole universe. The
Oh, we are
creator.
still on God topic only. Yeah.
So for example, I am an ecologist. So as an ecologist, what we know is the processes. But still, whenever we don't know anything, we say that it's nature which
Yeah.
controls it. So for us, nature is God. So similarly, for a physicist, how do you define who is the creator? Because see, so far what humanity knows is only the
So
processes.
I think we have gone back to the creator's question again. So Karthik, would you like to?
Maybe since you talk about ecology or something, so let's take an example of a bird, right? Birds, some migratory birds, daily go over the oceans and, over many months and reach their destination. How do they do that?
Exactly.
Right? For you, for us to think about it is probably, no, it's just nature as God doing this.
Yeah.
No, but as scientists, we try to understand these questions. So we actually try to probe what is there in the bird that causes this. And there's a scientific reason to this, which we now know that there are certain proteins or enzymes in the thing, which is very sensitive to Earth's magnetic field. And that gives directionality of how bird can propagate. So these are some examples where science questions this God-like belief. As much as possible, we try to answer. If we don't know, it's still open question. And that's the research that is ongoing. And we try to reach as close as possible to
So
God.
the basic thing we learned is, irrespective, I really love the way you guys are so calm and composed, unlike we see it on TV9 or NDTV, where all the panelists are losing their, but you guys are so, I think this is how basically we should argue and try to answer the question. And one of the major things which I picked up from you guys is that we should be okay with not knowing something. It's okay to not know, and to tell that facilitates the discussion rather than going back and forth respectfully. Okay, so now the God topic is done. If you guys have any other questions, we can take. Yeah.
We will be
You will be God.
We're 10 students here.
Oh, you'll be 10 students. Okay.
We are 10 students.
You are 10 students.
Now we'll be going into inter.
No.
So our question was, if we were to take science, what is the future of science? And we all know AI is coming up, and it will take most parts of science now. So what will benefit us in the future as science students?
So it depends on which college you're joining. See, nah, there's no future in science. I'm just joke. Don't quote me anywhere. Please edit it. I don't know, you guys are recording it. Don't put it anywhere, okay? I love Sri. Okay. So his question is more related to AI. What is the future? Because I'm sure a lot of people are scared that AI will take over. So
what does science teach you? It teaches you logic. It teaches you how to handle things that are unknown and how to go about figuring out things. What is done in the colleges, schools are some worked out examples that have been done in the past. Anytime you go into the real world, there are new things that are not done, new things that are not answered. But if you know how to do this logical thinking, there is a chance, whether it is artificial intelligence or some other intelligence, there is always room for logical analysis, logical assessment, and figuring out a solution to a problem. That's what science is.
Oh, you want to add anything?
So don't be afraid. Your jobs are secure when you grow up. But, even in the world of AI, there are so many things that you probably will be learning. For example, how to use an AI tool itself is an art. Okay. And that's something I think now the kids are learning. My son now, whenever he has any homework question, I try to avoid it, but when I'm not around, quickly open the laptop, he tries to get some answers on ChatGPT or Gemini. But this is a tool that will probably take you forward in terms of asking more questions, and train you in a different way. So there will be new kinds of jobs or new kinds of opportunities that we at this stage are also exploring, and it will come up. So don't worry about your jobs.
So basically, to add to them, just focus on learning skills. The more skills you have, the much better. Worst case scenario, we welcome you to stand-up comedy. Okay, we can do that, okay. So you have a question? Yeah. He gave because same
Hello, I
t-shirt.
am Nishika. I am a BTech student. So what advice do you give for a student who find these topics intimidating?
Oh, okay, so when we don't know something, it looks fearful, it looks intimidating, for sure. When first time you encounter darkness is intimidating. A room where there is nothing, but if you don't have a light there, it looks fearful, right? So best way is so what do you do in a dark room? You sit there for some time, open your eyes, and then your pupils will dilate, you will see more light, and then it becomes comfortable. So you have to practice you don't have to climb Himalayas in one shot. Small steps, small hills, gives you strength to solve bigger problem and go forward.
Karthik, you want
That's perfect. I think that's exactly what the research is all about. You just have to make sure that you always are eager to learn and develop skills. that will take you.
Be curious.
Be curious.
And another best way to learn is to teach. What you learn, you try to explain to somebody else who doesn't know. I mean, it could be your grandmother, your grandfather, doesn't matter. Go and tell them what you have learned, explain to them in a way they can understand. If you can make them understand, then you have understood.
It's like almost Richard Feynman technique of learning.
Yes.
That person has been like trying to ask a question from a long time. Yeah.
Hello, sir.
Hello.
This question is for you.
Oh! Excuse me, yeah.
So,
What is the question?
so could you explain to us how you do comedy scientifically?
It's a probability actually. You take a joke, you put a probabilistic value on it. It will work 5% of the times. If I tell the joke to my mom, it may not work. But if I tell to the audience, it might work. So it's a probability. Process, yeah, this is the process. We keep testing the jokes. Like I write a joke. So a lot of depression goes into the mind. I look at things, the way things are, and then I take in all the depression and then try to find something funny in it. And then I tell it to my friends first. I tell all my jokes to my friends first. And sometimes they don't listen, sometimes they block me. I make new friends. Friends are the first step where you tell your jokes, and then you take it to a small group of open mics will be there, where you can go test your content. They did not pay for the show. They're just hanging out in the coffee shop. You tell jokes to people who are just hanging out in the coffee shop. And even then the joke works, that's a good joke. So then you take it to 60 people show where you charge only 200 rupees. Then you take it to 60 people show where you charge 500 rupees. Then finally 1000 rupees people, then you tell the joke. And if it doesn't work out, then you are bad.
And then you put on YouTube, and then
I
if you
put on
get
the
a million,
YouTube,
then you
and
get
then
money.
you get money. So that's the process. So, but the crux of it is keep testing the joke until it works. So, or you keep changing something or the other. Yes, ma'am. You have a question? Yeah. We all have questions. I think we'll take like final 2 questions, and then I just have like summarize and then, because my summary might take long. So that's.
So my question is, how do we introduce the concept of quantum physics to an 8-year-old who is from a government school? Because I'm really tired of the education system making kids into herd mentality. So how do we inculcate the curiosity and also make them understand in a very simple terms?
I think this is for both of you.
Yeah. So as I was trying to explain just a few minutes ago, I was talking about it. So when people stand in a stadium, and there's waves that go on. So nobody is moving around, but there is something that is moving around. We call that a wave. And waves are something that is there realistic in, when you throw a pebble in a water, you will see waves. The water is just bouncing up and down, but there is something that is moving across. What quantum mechanics is nothing but that, applied to even particles which have a mass. Like a pendulum that is moving around, a ball that is being thrown. Normally there is no wave associated with that. It's only a particle, and it is moving from frame to frame, from position to position. But when you go into a macroscopic world, if you can associate it with a wave, then you can work out everything about its motion, about where it is, how it is manifesting itself. I think that's a good starting point to understand, introduce what a wave is and the concept of a motion of a wave.
Karthik.
So I have just 2 short answers. One is within my reach or within our reach. So this is something at TFR we do, and there are other institutions like BITS, IIT, others also do have an outreach program where we do have people, and that's where Anushila really takes the lead, brings in high school students of 8th, 9th, 10th. So it's the best way for them to be engaged in sciences to actually experience it. So we do have them from high school students, even government schools coming over, looking at the campus for a one-day tour, getting them experience of what science is all about. And that's something gives them a curiosity. Often we have found some of them in the end of 11th or 12th, or they come to us for internships or just 3 months duration, and it changes a life. I have seen examples where I have trained a student in 11th, and he's now went to the US and doing his science. So this is something, it's a very small part of it, but I think can be done. Secondly, on a larger scale as a society, I think this is where I personally, of course, it's too late for me, but when I went to the US for my PhD, that's when at Boston I realized you have fantastic science museum. I mean, there the kids right from age 6 or 5 come over, see very interesting, shows, very interesting problems where they can tinker with it and build in curiosity. And I think as a community, the science museum is something very important. Hyderabad is a perfect city, and then take it to Tier 2, Tier 3 cities. But I think Bangalore has done. I haven't visited
Bangalore
science
has,
museum.
and my favorite science museum is in Coimbatore. So it's like amazing. So they have so many experiments. I spent almost 8 hours there, just doing experiments. There were like one kid, I pushed the kid and I started. It's brilliant. So maybe I think Hyderabad should also have a science museum. Yeah. Okay. Yeah.
So this was really fun. Thank you, all three of you. Rajashekhar, my question is obviously to you.
Okay. Thank you. Yeah.
I mean,
feeling important right now.
other than Anushila threatening you to do this, what motivates you to engage in science? What is your relationship with science?
No,
yeah.
I love science. It's amazing.
You don't have to say because we are around.
No. No, I think in the hierarchy of people I should be scared of, I think scientists will come at the very bottom. So I'm not scared of you because I know I can disagree with you and I still go back feeling good about myself, So that is something which I love about science. I started reading a lot of science books. One of the first books I read was this called The Biography of E = mc square by one person called David Bodanis. So it's about the equation E = mc square. It doesn't talk about the people, it talks about the biography of that equation. So it talks about how energy came up to be, why m is there in that equation, why c is there, and why is c square. So, and when I read that book, first initially I thought maybe I won't understand it because E = mc square, I never understood it. So then when I read it, I was like mind blown with the storytelling. I finished the entire book, maybe 340 pages in one go. I didn't even get up from Starbucks. Every employee in Starbucks came and told, sir, you should leave. I just finished the book and leave. So it's an amazing book to read. From then on, I keep in touch with all the things which are happening in the science world. And I myself have a show called Science It Up. I didn't want to do it, but they forced me to put a plug in here, okay? So I have a show called Science It Up where I talk to my audience about science concepts in a funny way. So every time I do the show for half an hour, I feel bad about myself. Why am I putting myself through this? Because I was just talking to them outside that a lot of people, when they come to my show, obviously comedian, I have to crack jokes. But some of the topics I can't explain to them, like this lady who was facing the trouble. So I don't know the correct analogy, right? So, but I'm trying my best. And I think that is one show I will never put it on YouTube. Because if you want to see that show, you have to come to me. Because I feel the communication should keep happening. And today, whatever happened today, I really loved it. I immediately agreed the moment Anushila said, even though I couldn't get in touch with you before. So I really love this because this is something which society needs right now, I feel. Because we need to keep talking to each other, we need to keep arguing. You have so many good points. Some people have doubts, and that guy got wedding. So it's amazing. So that's why this is something which I love. So, and I hope all of you develop a scientific mind. Before we wrap up, I have one final question for both of you. You just answer in whichever way you can. The question is, with the current state of affairs in the world, from a scientific perspective, how hopeful are you about our civilization? If yes, why? If no, why?
Things are getting dangerous. There's no doubt about it. Because when we didn't have the kind of potential that the science opened up, things could go wrong, but in a local, limited way. But now the science has given the reach which is beyond any imagination. So it is a dangerous world, and people have to understand that we also have a responsibility. A responsibility not just for us who are living on this planet today, but responsibility for the future, because we shouldn't empty this planet in the near future of our imagination.
Okay. So what about you? Are you hopeful?
When you say civilization, you meant specifically India or the world in general?
The universe.
The universe in general.
Wherever they are. Multiple. I've seen that there are multiple universes, it seems.
Yes.
Avengers
Good.
may. So they can.
With a fine probability.
Yeah, probability. Yeah.
So I think I'm being optimistic, and I think as scientists, we're always optimistic in the things we do and things that we perceive will happen in the coming generations to come. So I think overall, there's nothing much I would like to add, in case already mentioned, but I think being optimistic is what we have been trained to be as a scientist.
That almost brings us to the end of the session. If any one of you have questions, you guys can still, do we have questions? Can we take, or are we done? Overshooting, okay. So maybe you guys can ask them questions outside. They will be available. One last question. If it is quick to answer, then only we'll answer, okay?
Yeah, I'll ask a question.
Yeah.
So many years ago, there's many other great scientists and people. Like, we'll take the example of Ptolemy. And then at that time, according to the technology, he has only discovered 5 planets. And according to the technology at that time and all the things that satisfies, all the agreements and all the arguments and all, there were only 5 planets. And others could not discover any more planets. So right now, when we, according to our, as the technology increased and all, we could identify there are more planets, and that's wrong. So what if right now also there are many things, many questions and all that are actually wrong, and we don't know it, but everything that, the questions that we ask and the arguments we think actually satisfies, but in the future that may be wrong, according to the technology. How do we deal with those things? Because we learn right now.
From a technological perspective or from a human perspective?
Both.
No. So answer is short that what you all said is right. I think you should become a scientist.
So there is a book called Things We Don't Know. In fact, it's a fantastic book because all
it's called DBMS, right? DBMS, no? The data structures and management.
No, all the science we know, it actually answers only very small percentage. There are things called, there are lots of puzzles which are, forget seeing the planets. There are bulk problems in the sense of, where is the mass of the world, where is the energy of the world. There is a huge paucity in our understanding and our ability to account for what is there. We know that it is there, we can measure it like the way we can see the planets, but we don't know what it is. It's called dark energy or dark matter because we don't know it. Dark because we can't see it through any light that can travel to us. Majority of the world actually is that. What we know is only 3%. So there is a lot of things to do. What we have done is very little. The problem is people think that with the little that we have done, should be satisfied, and because the economy is working well, we are getting jobs to do. But there are a lot more things. Could you have imagined AI 40 years ago? Right? So there are, what we know is very little. What we don't know is huge, immense. What we can do with it, since we don't even know what is there, we can't say what we can do with it. So there is a lot to question, a lot to try to answer, a lot to build. Even a bacteria or a biology microorganism, what happens there, we still don't know. It's going to take next 100 years for us to understand exactly what is happening. We can understand it to some extent to be able to make use of it to push for economy, push for some applications. But there is a lot more need to know.
Thank you so much. Can we have a round of applause for both Mr. Krishnamurthy and Karthik? Thank you so much for joining. And thank you all of you for being very patient and very interactive. I think we should do it more often. We should just keep interacting with all of us so that we will get a hint of what fun you guys are having at the top level. And please keep questioning everything, and not me, but everything. And be curious, be open. Thank you so much, everybody. Back to you.